Hello, everyone, and welcome to QTRIC's second annual Zero Emission Bus Technology in Transit Operation Conference. My name is Magali Franette, and I am one of the Membership Success Officers at QTRIC. And it is my pleasure to welcome you to our sponsored keynote with Hitachi Energy. I'm joining you today from Neuville in the province of Quebec. And in the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Huron-Wendat Nation. Again, welcome to the sponsored keynote with Hitachi Energy. And today, we have the pleasure to welcome Ahmad Shukair, Account Manager at Hitachi Energy. Ahmad has a great presentation for us today on the RTC pilot project right next door here in Quebec City. So let's get started, and the virtual floor is all yours, Ahmad.
Well, thank you, Magali. So thank you for inviting us to this panel. I'm going to talk today about the project we recently won with the RTC, Réseau Transport de la Capitale in Quebec. So I don't see the screen for the, yeah, there we go. Thank you. All right, perfect. So as you may know, Hitachi Energy, we developed charging infrastructure, mainly for the e-bus sector. So we work closely with transit authorities such as the RTC and a lot more in Canada. And essentially, the RTC project for us is a great milestone for Hitachi in the development of the product, but also for the technology itself and how it will be deployed in the upcoming years. So I'll talk a bit about what's the challenge that we're facing and how we're gonna try to accomplish. Also discuss our solution, the Grid Emotion Integrated, our digital approach, and how we, Hitachi Energy, have developed a roadmap for the future and help these transit authorities adapt to the transition from ICE vehicle to electrical vehicle. So first of all, let's discuss the RTC project. So like all the other transit in Quebec, they have a new ruling or new government law that says that the government will stop funding these societies or these transit authorities. They will stop funding the purchasing of ICE vehicles, so internal combustion engine vehicle or hybrid vehicle, and they will only finance electric vehicles. So, and that's by 2025. So that puts a lot of stress on these authorities to electrify the infrastructure and select the right technology. And they have different bus depots to adapt. They need to purchase these buses. They need to develop the specification for these buses. So they come up with this project called the PBLX project, which is in progress. And in order to face all these challenges, they went with Novabus with the LF SE Plus platform that they will receive roughly at the end of this year. And they went with our technology, our charging infrastructure technology, the Grid Emotion, which I will present the next slides. So essentially, the purpose of this project is very simple, right? So they have roughly 3 years to figure out how they will develop, integrate, and electrify their fleet, as well as their bus depot infrastructure. And they need to test the charging, the technology, the interoperability, the different charging interfaces, and you will see with my presentation what I mean by all this. So first of all, let me explain what we do here at Hitachi and how we came to convince the RTC to go forward with us. So essentially, like you may all know, the standard, or I would say what we know for the past couple of years is the charger is a unit, standalone unit, so a product that you can connect to an AC grid and it will output DC. And if you have one vehicle, it's one charger. If you have two vehicles, two chargers. If you have three vehicles, and so on and so forth. What we bring to the table here is we tell uh, the transit, you don't need to necessarily have one charger per vehicle. And again, I'm talking very high level. You can have one charger and then have sequential charging, so you can have 1 to 3 vehicles. But the idea here is we approach the problem at the root. So we say we're going to develop a solution that's going to enable these transit authority to move forward with one simple infrastructure that's going to have a unique point of conversion from AC to DC, and then that point of conversion is gonna connect multiple DC chargers, and these chargers will connect to charging interfaces and then connect to the electric vehicle. So by doing that, we remove a big portion of this whole solution, which is the low voltage. We connect directly at the medium voltage, 25 kV or 44 kV, depending on where we are in the country. And we also reduce the footprint, right? We don't need to have spaces for all these individual chargers. We also reduce the amount of cables that are going to be necessary for the development of the project. So in general, this is the idea of our solution. What we're gonna deploy with the RTC is the following product. So what you see is a render of the grid motion fleet integrated. So essentially here, for the sake of this project, we're going to connect at 600 volt, so low voltage, and then we're going to have a transformer, a rectifier transformer. This rectifier transformer is going to feed a rectifier, and then we're going to have a DC bus. And on the complete right of this image, you see the DC chargers. So this comes like a container, very simple to install. We ship it to the customer, they install it to the ground, and we connect it to a low voltage distribution breaker. And there you go. It's as simple as this. For sure, there's some civil work to be done, but it's very easy in terms of the deployment. And then after that, I'm going to explain the other capabilities of this solution. So what we offer here with the DC-DC modules is the possibility to offer sequential and simultaneous parallel charging. So in the illustration on the top, we see each DC-DC module is connected to 2 charging interfaces. And based on the buses and what needs to be charged, there's a contactor that's going to open or close, and we're going to charge either the first or the second. So we will send 100 kilowatt to the first interface, charging interface, or 100 to the other. So essentially, we have one DC module that can do 2 charging interface up to 100 kilowatts. Now, the other strategy that we have is a one DC-DC module, so 100 kilowatt module connected to one interface, but then we connect the interfaces together. So now we have the power of charging each interface at 100 kilowatts, but if we decide to power boost one, we can bring all that energy from 2 modules to one interface, and we can get up to 200 kilowatts just by closing in a contactor. So this flexibility is something that helps a lot during the operations, and one of the most important things for these transit is keep the service reliable and be able to always provide the buses on time. So next is the different interfaces, charging interfaces that we're going to deploy. So we have the retractable cable, motorized. We have the wall mount CCS plug, and we will have two types of pantos that we're going to deploy. So we have the on-road panto and the depot panto, and all these are we're going to test the interoperability. We're going to test the simultaneous, the sequential, and in the hope of testing it also with different OEM manufacturers. So we're talking Novabus and other types of buses. So in order to control all this, what we've suggested is to have what you guys see here is a 4-component in terms of remote access charging. So first of all, we enable access remote from anywhere, right? You through a VPN through your computer, you go online, you log into your credentials, and you have access to see what's the charger status, what's happening, is there any alerts, is there anything wrong, or everything is going smooth. Now, if you have multiple chargers, of course, you have a map visualization, and you can hover your mouse and you can see information. You can also do reports and trends, and you can filter and see what you want. But this is something that is going to be deployed with the unit for that particular project. So now that I've talked about this project, I see the time is flying, so I'm going to jump on the roadmap that we have here from Hitachi. Here you see the stairway of value that we call it here. Essentially, it's 6 steps. So the first step here is, and again, this slide is for the digital component of the e-mobility roadmap that we have here at Hitachi. I'm not going to talk necessarily about the physical, technical charging, but the digital aspect. So the first thing is we want to connect to the charger, so remote access, but also have access to the vehicle. And this is something we already have. So we're talking about telematics. So we can see the SOC of the buses in real time. We see the status of the buses in real time. And now, with that information, what we want to do is we want to also, on the second level, we want to implement or integrate the schedule of the fleet. The schedule of the fleet, the information about the rates of electricity, and that will enable us to do what we call the smart charging. So peak shaving, load shifting, and that sort of control. The third step is the analysis. What we do with the analysis is we implement what we gathered in the first and second level, and we bring another aspect. Now we can take decisions to increase our efficiency in terms of charging. The third level, now we have all this data, we can use it with algorithms to potentially optimize the OPEX, so our operational expenditure. How we do that? Well, there's different algorithm based on the status of the battery, the charger, and so on. On level 5, we take what we learned from the 4th, and now we do prescriptive analysis. So now what we do is we order the parts, everything is automated, we schedule the maintenance, and so on. And on level 6, what we do is everything, and that's something we haven't achieved yet. Level 6, we've achieved already the 1 through 5, but 6 is something we're working on. And essentially on level 6, what we do is we want to do the optimization of the whole thing and have a very a strategy to work uphill. So we, as soon as we receive the asset, we make sure to keep it as long as we can, right? So how can we, let's say we receive a bus today, how can we make sure we don't we keep it for the 16 years? Then what we do is we look at the types of charging, but also now the driver behavior and a lot of different analytics. So I've brushed through this presentation. I see the time flies, and again, we can keep talking for hours and hours.
Absolutely. You're right, Ahmad. Thank you so much. Great presentation with lots of information. Really wish we could have more time to go for Q&A and actually add questions for you, but let's leave it out and continue next time. So thank you so much. And thank you to our great audience for joining us. If you would like to continue this dialogue, please join us at our virtual networking taking place in about 15 minutes, right after the closing speeches that is starting right now. So thanks again for your participation today. And if I don't see you at the networking, I'll see you tomorrow for day 2 of the Zero Emission Bus Technologies and Transit Operation Conference. Thank you so much, Ahmad, and I'll see you tomorrow.
Thank you, Magali.
Yeah, so now I would like to welcome my colleagues, Grace and Melissa, on the line for the closing speeches.
I think it's just you and I, Magali.
Yeah, great, excellent. So let's get started, or let's finish this up. Bonjour à tous et merci beaucoup de vous être joints à nous pour le premier jour de la 2e conférence annuelle du CRTUC sur les technologies d'autobus et les opérations de transport en commun à zéro émission. Sérieux, quelle belle journée, là. C'est grâce à nos présentateurs, puis aussi à vous, le public, avec toutes vos questions plus pertinentes les unes que les autres. En plus d'accueillir 8 panels, 3 discours d'honneur avec des experts provenant du transport en commun, de l'industrie, des services publics, du monde académique, des organismes sans but lucratif et bien sûr du gouvernement. On a également eu une super annonce ce matin avec la secrétaire parlementaire du ministre des Affaires intergouvernementales et de l'infrastructure et des collectivités, Jennifer O'Connell. On est vraiment content d'annoncer que le CRTUC a été nommé le Service national de planification du Fonds des transports en commun zéro émission d'Infrastructure Canada. C'est vraiment une belle réussite pour notre équipe. De plus, aujourd'hui, on a lancé nos nouveaux outils de modélisation, les nouvelles versions. Puis, on a en plus un souper en personne ce soir à Mississauga. Alors, c'est la cerise sur le sundae. Sur ce, je vous invite au 5 à 7 virtuel. Je veux vous remercier. Je veux remercier nos commanditaires qui, sans eux, c'est impossible de faire une conférence de ce niveau-là. Puis, je vous dis à demain.
Hello again, everyone. Thank you so much for joining day 1 of CUTRIC's 2nd annual Zero Emission Bus Technologies and Transit Operations Conference. What a day. We don't do anything by halves at CUTRIC, and I think we might have hit a new record today. On top of hosting 8 panels, 3 keynotes with experts from transit, industry, utilities, academia, not-for-profits, and government, we also had a very special announcement this morning with Parliamentary Secretary to the Minister of Intergovernmental Affairs, Infrastructure and Communities, Jennifer O'Connell. I'm thrilled to share that CUTRIC has been named the National Planning Service for Infrastructure Canada's Zero Emission Transit Fund. It is a long time coming, and we're just so thrilled that it's come to fruition, and thanks everybody for your support. We're excited to support transit agencies and municipalities plan their way to a zero-emission transit fleet. So if you would like to learn a little bit more, please contact us, and you can do that via email or visit our website and check out the chat box there. We're happy to help you out. We also launched CUTRIC's ZEB Consulting Services next generation of tools, RTI 3.0, our predictive modeling tool, and Cloud Transit 2.0, our empirical analysis tool. We also launched a brand new product, RTI Lite. So check those out as well. You can visit our website to learn a little bit more and contact our team today. We are also hosting our first in-person event in 2 years this evening. So starting in Mississauga, we are thrilled to welcome you there. So we will be joined there by several people across the industry. Sponsored ABB keynote. We have a keynote from Anne-Marie Carroll from York Region Transit. And we also have Associate Minister of Transportation, Stan Cho, joining us for a keynote session. So really exciting times. But I know not everybody is able to join the in-person event, but no need to worry, you can join virtually. We are streaming this across our platform here. So you can tune in from 7 to 8 p.m. Eastern time if you would like to hear from those people. So before we move into our virtual networking session, starting just shortly, I'd just like to say a final thank you to our sponsors. Without you, it really wouldn't be possible to put on this conference. So thank you to our platinum sponsors, ABB, New Flyer, MCI, Alexander Dennis, Arbok, and NFI Parts. Our gold sponsors, Ballard, Zev Clean Power, Ricardo, and HDR. Our silver sponsors, Hitachi Energy and Nova Bus. And our bronze sponsors, Siemens and Innit.
Merci beaucoup tout le monde. Je vous souhaite une belle soirée, puis je vous dis à demain.
Thanks again, everybody. Take care. We'll see you all at the networking session starting in 15 minutes, or we'll see you for day 2 tomorrow. Take care.